Let us understand how machine learning workflow works. Machine learning cannot happen all of a sudden. We need a huge amount of historical data to predict what's going to happen. I need to know what happened in the past. Only with the historical data I can predict what's going to happen in future. Let us take an example. I have huge amount of historical data. In this case, what are all the products or different parameters? Let's say 40 parameters about the user and whether the person bought the product XYZ or not. In this case, let's consider I have 40 parameters about the customer in terms of what is the average salary, whether they do have credit card or not, recently bought a car or not, whether they do have their own property, and number of children, how many age, and how many dependent person. So all those parameters, let's assume I do have this information and I do have a value on whether the person bought a product that is XYZ product or not. So I do have the data. Record 1, the person bought the product. Record 2, the person bought the product. Record 3, the person did not buy the product. Let's assume I do have like this 1 million records. Now I wanted to identify what is the pattern within this 40 parameters which is going to drive whether the user would have bought the product or not. So what I will do, I will segregate this particular data into two different categories, that is the trained data and test data. Generally we will separate this into 80-20 or 70-30. In this case, let's separate it into 70-30, that is 700,000 records. Randomly I will pick, I'll make that as a trained data, and I'll keep 300,000 records apart for the testing purpose. I call this as a test data. Data scientist will provide me an algorithm or a set of algorithm to use and to extract the pattern within this 40 parameters, that is the model or the function that's going to represent what is the dependency of these 40 parameters that's going to determine this particular final value or labeled value whether the user have bought this product or not. So using n number of algorithms, I may generate n number of models. Let's assume I am using 3 algorithms to generate 3 different models. So let us assume I am using 700,000 records to identify 3 different models using 3 different algorithms. In this case, I have used algorithm 1 to generate model 1 and algorithm 2 to generate model 2 and algorithm 3 to generate model 3. Now the model is nothing but a complex function where I can provide these 40 parameters, and that would predict me whether the product or the person or the user would have bought that particular product or not. So what I will do, I will use this 300,000 records as an input. And for this 300,000 records, already I know whether the person have bought the product or not. They are all the actual values. And by feeding in these 300,000 records to these different models, I will predict whether the user would have bought the product or not. So they are all the predictions. So this is prediction with model 1. The same way I'll make predictions with model 2 and prediction with model 3. Now I'll be having 300,000 records or 300,000 predictions for each of this model. These all are the predictions and I know the actual value. I'll be comparing these two. How much amount of accuracy I have got. So whether this model is effective or not, I can compare with the actual value and the predictions. For each of this model, the predictions that I have made, I can find the accuracy. Let's say model 1 got me 56% accuracy and model 2 got me say 78% accuracy and model 3 got me 72% accuracy. And no machine learning can provide me 100% accurate result. So out of all these 3 algorithms, model 2 works out to be the best, and the data or the algorithm 2 works out to be the best. I'll choose this particular algorithm. I'll work against the data and I will generate the model. I will use it in the production for my prediction purpose. And depending on the data type, the algorithm may vary. For the same similar data, for a different geographical location or for a different organization, the algorithm might not work. So algorithm also it's going to have an impact on the type of data or the type of domain that I am working on. That's why we always go with this particular test methodology to predict which model or which algorithm is working best for that specific organization. And data scientists will continue to work on improving this particular algorithm by finding out various algorithms, various parameters, and doing this particular prediction methodology and comparing with the actual value. They will work on identifying the best algorithm for that specific organization. In case in future if they come out with a model where it's providing me more accuracy, let's say 80%, then they will use that particular model in the production scenario. This is how most of the machine learning algorithm works, where we will be using it for prediction, and what I am going to predict, whether I know that value already or not, that's what is going to be the type of machine learning that we are going to learn.